Hello, my name is Sydney Williams Ridley. I'm a first year integrated biology major from Silver Spring, Maryland.
Hi, my name is Michaela McPherson. I'm a first year psychology major on the pre-med track, and I'm from Chicago, Illinois.
Hi, my name is Michaela Smith. I'm a first-year psych major on the pre-med track in Prince George's County, Maryland. Our project is about the birds of prey migration patterns with respect to temperature in Purple Chickadee-HawkWatch site in New Jersey. Starting off, birds of prey hawks are birds of prey that pursue animals for food. They belong to the genus Occipiter, and there are over 200 species. The lifespan is typically between 10 to 20 years, and they range between 7 inches and 27 inches. They usually weigh up to from 3 ounces to 5 pounds, and they're on every continent except Antarctica. Birds usually migrate, and bird migration is the annual relocation of the birds. Usually, birds migrate in the fall seasons between September and October, and they travel 15,000 kilometers, 1,500 kilometers, excuse me, depending on the weather. Hawks prefer to migrate during moderate and dry temperatures because it's easier for them to soar through the sky rather than flapping their wings up. In a study by Franz Berlin, he mentions that birds, there's a lot of aspects that affect bird migration, such as food availability, weather, and competitors. The site that we chose was the Purple Chickadee-HawkWatch site, which is in Brentwood, New Jersey. And this site is a residential area, and it is an eastern deciduous forest, and it's also in a valley between two ridge systems. The methods to gain the information that we did came from or was used by various tools such as binoculars with multiple magnification, weather readers, etc. The birds were often spotted based on color, pattern, and size. When conducting this experiment, we first went to the HawkWatch site, hawkwatch.org, to gain our location and selected our site. Then we got our data, collected our data from the site, which was basically the abundance of birds for each day during the fall season, as well as the temperature for each day in the season. Then we used Excel to analyze the data by making different charts and graphs from the data that we got.
All right, so when looking at our investigation, we decided to do our research question based on the temperature, which was, do different species of birds migrate at different times based on environmental factors like temperature? And we hypothesized that most birds would migrate when the temperature is moderate and satisfactory for their species and the characteristics of their species, which led us to the prediction, which was that most birds of prey would migrate most abundantly towards the middle of the season because we figured that's where the temperatures would be most moderate as it's cooling off from the summer, but not so cold that it wouldn't be in the winter.
Okay, moving on to the data aspect of our project, looking at the first figure, we can see that it represents the daily abundance for birds of prey in the fall season. And as you can see in this line graph, there is a large spike of bird migration for the broad-winged hawk. That would be the yellow line that you see. And this is during the dates of September, where the temperatures are moderate, not too hot and not too cold, and good for migration. We predicted that this is when the birds would most likely migrate during this time in September because the temperatures are usually high 60s, low 70s, and that's when they would tend to migrate. Looking at the second figure, figure 2, the bird of prey daily abundance, as you can see, it's a scatter plot where the bird of prey that shows bird of prey daily abundance, where the y-axis is the temperature and the x-axis is the abundance. And as you can see, the points are, excuse me, really clustered around the moderate temperatures. And there's not that many points far off, so there's not that many birds migrating to start off with. And then as you see, the points are clustered around the temperatures in the middle, not many points around like lower temperatures or high temperatures. And that just shows that birds, just like we have stated, that birds like to migrate when temperatures are moderate. And for this scatter plot, the R value of this graph is very low. It was only 0.004, which explains that for this graph, as temperature increased, the amount of migration does not increase. Like there is not a positive linear relationship between temperature increasing and the amount of birds migrating. Because like we've stated, birds don't want to migrate when the temperature is really hot or really cold. So as you can see from that, there's no linear relationship between the temperature and bird migration abundance. And then moving on, the p-value for this scatter plot was only 0.01, which is fairly low. The p-value is really just saying like how likely our null hypothesis is to be true. And our null hypothesis is just saying that there is no way that temperature affects bird migration. And from our study, we can see that that isn't true. So the p-value on this graph is only 0.01 because it is not likely that temperature would not affect bird migration. So therefore, that this graph supports our hypothesis that temperature does affect bird migration. Moving on to figure 3, as you can see, this shows the abundance for each month during the fall season of bird migration. And this first figure, figure 3, shows that September has the most migration for birds. And that's what we originally predicted because the temperatures are moderate, not too hot, not too cold. But in this figure, the broad-winged hawk is still included in the data. And as you can see in the figure 1, the broad-winged hawk was the species that had the largest spike. And you could really call it an outlier. So with the broad-winged hawk being included in the data in figure 3, September is the month with the most bird migration, which is how we originally predicted. But with this in mind, looking at the figure 4, we actually took out the outlier of the broad-winged hawk. And as you can see, October is now the month with the most migration of birds. And this shows like, although our hypothesis is still supported that temperature has an effect on bird migration, we can see that when the outlier is taken out, October is now the month with the most migration, which also leads into another aspect of our study that has to do with weather, and that's climate change. Because originally, like I said, we predicted that September would be the month, but when this species was taken out, it was now October. And according to the article, Are Bird Migration Dates Shifting? A Review of Weather and Climate Effects on Avian Migratory Phenology by O. Gordo, this article focused on how weather and different climate patterns can affect timing and process of bird migration. And it mentioned how climate change increases or like causes birds to travel earlier or later in the season. And this is related because our spike showed that the migration was in September for the broad-winged hawk, but usually bird migration, or we predicted that there would be mostly in September, but it was actually in October. And this shows that like as temperatures and climate continues to climb and get warmer, there will be shifts in the time that birds migrate. Some species of bird may start to migrate earlier, like the broad-winged hawk, and there'll be huge spikes in September, or they'll start to migrate later that in the season, and it can just have a lot of effect because that climate is changing and it can change when birds tend to migrate. But overall, the data does support our hypothesis that temperature does in fact affect bird migration, even though we had outliers that somewhat skewed our data at some points. But for the future, overall for our project, we would definitely research our site more before we chose it for a project because the Ringwood Purple Chickadee, New Jersey site, it was a good site, but it was definitely lacking in a few areas of information when it came to like the methods and things like that. But overall, it was a good site for the study. So now we're going to move on to the results.
Thank you. So overall, our results found that as temperature drops, migration drops. We also found that broad-winged hawks made up most of the abundance for our data, which ended up skewing it to look like September was the most abundant month for bird migration when it was actually October, but that's kind of only in terms of species diversity. We also found that migration was most active between September and October, which had supported our initial prediction that they would migrate most abundantly in the middle of the season. It kind of supports the idea that the temperature needs to be really moderate for them to feel comfortable migrating. And so when we think about what's next for this project, if we were to continue it and do it in the future, I think I would want to keep looking at these migration patterns for future years to come and kind of compare it to the data that we already have, and just kind of see if there are any continuities within it. I would also look at different factors other than temperature. I'd also look at diet, wind speed, precipitation, all of that stuff, and see if that is another thing that would impact bird migration. So to conclude this presentation, I would want to thank Dr. Dash for inspiring us to do this project. I also wanted to thank the Biological Science Department and the Psychology Department of Hampton University for giving us that support and a foundation for us to be able to do this project, as well as finally thanking the National Science Foundation for funding our investigation. Thank you.